All right.
All right. So I'm going to pull this over. Oh, this was a bad choice. Let me change the theme of this real quick. Change the theme. Make it like. All right. So this will be a little bit of like discussion QA style. Let me make this into present mode. So there's not a whole bunch of slides. I was just trying to type up real quick some of the things I remember as far as parameters go. So OAuth2. What do you know about OAuth2 currently?
Better than OAuth1.
It's better than OAuth1. That's debatable, actually.
Yeah, I was just reading something that said there's some security issues with, or possible security issues with OAuth2.
Well,
I didn't get into it.
there are definite security issues with OAuth2. There are also definite security issues with OAuth1 and 1A. I mean, there's definite security issues with every technology, and you do have to mitigate that. So we'll talk about that a little bit. I'll put a pin in that to talk about security issues. Because there are some important details to consider. The problem with OAuth2 is that it assumes that you're using HTTPS and that HTTPS connection is already good, which I think is not a great assumption because there are so many people that aren't using HTTPS yet, although there isn't really reason that you shouldn't be. Have any of you heard of Let's Encrypt?
No.
Okay, so this putting this on your calendar. Probably in August. There's not like a specific release date yet, but you can check out let'sencrypt.org for updated information. Mozilla is giving everyone in the world free SSL certificates. So at the end of this year, there will never be a reason for you to ever have any site, even for a demo, without SSL certs. So they're building Go, Python, and Node libraries right now, and I would imagine that at some point the Ruby people are going to get on the bus as well and make a contribution to that. So maybe you could be the guy, but that's looking good. But as HTTPS has issues of its own, especially with where we're going forward with the peer web and devices where everybody needs a certificate, and sometimes you're actually using the same certificate kind of thing. But anyway, other things. What do you know about OAuth2? It is good for what? It's best for what?
Single sign-on.
So single sign-on, that's the primary purpose of it. I'm actually working right now to try to get it to be my only sign-on, so that the framework I'm working on, I'm trying to get it so that I actually don't use anything except for OAuth to log in. And if anybody heard of JavaScript web tokens before?
Yeah, they're awesome.
Yeah, so like a combination between like JWT and bearer tokens. We'll talk about bearer tokens. You can totally have sessionless logins where it's your client that manages the session, and you get some security benefits there, you get some speed benefits there, user experience benefits. Other stuff we know about.
So using JOT along with OAuth2?
So
JWT?
yes, you can. So other things we know about OAuth2. Where is it used?
On the internet.
It's used on the internet. It's used on Facebook. So Facebook uses it in your browser and on mobile apps and with servers.
Don't they also use it when you see like an embedded thing in somebody else's web page, like a like button? Does that authenticate your session with
so that's just using cookie authentication.
All right.
So that's because you have an active session. When they get that resource, your session cookie goes with that
So
resource.
it feedbacks on your...
But you can actually do that through bearer tokens and JWT as well. But that's, I probably won't talk about that. Okay. So there are a couple different strategies. And I was Googling to make sure I get these right, because I swap between these, and they're called different things because there's the technical name for it, and there's like what people actually do with it. And so sometimes there's confusion about that. I think there are other strategies than these, but these are like the 4 strategies that you see everywhere. There's some other strategies that are like for hypothetical situations that actually don't exist, so no one's implemented it in any of the libraries. But these 4 strategies you get in many of your OAuth2 libraries. Certainly not all of them. Almost every library implements this strategy, authorization code. This is your typical browser server authorization. So what happens there is, where'd that marker go? What you get is you have a browser. I wish actually, let me see if I can Google a resource where I can bring that up on the projector, because it's going to be too dark to draw it. Let's see.
You can turn the light on for a minute while you draw.
Yeah, we can do that.
Okay, let's.
I'll do that.
All right, hit that.
I'll make myself useful and do something.
And this guy's got a pretty decent. Okay, if you Google OAuth2 simplified, this guy has bits of code and a little bit of like diagram stuff that is pretty easy to understand. I've actually referenced his a little bit, so it's just if you Google OAuth2 simplified, that blog article should be the #1 hit, even if you're not me. I would hope.
It's simplified or simplify.
Simplified, OAuth2 simplified. It's an article by Aaron Perecki.
I found it.
Let me go back here real quick. And then actually, let me make this totally blank here. There we go.
Here's on the URUG Slack channel. I can paste it there.
Yeah. All right.
Just blew my mind.
So authorization code is what you're most familiar with, and so we'll go through the Facebook example, right? So you've got Facebook over here. We'll just call this FB. This isn't a browser, right? So put a little X and a little icons, whatever, right? So you log into Facebook, or you don't log into Facebook, but there's another site that's awesome, right? And this is in another browser tab. And you want to log into Awesome, so there's a little like lock icon or person icon or account or whatever, and you click on that, and what it does is that calls a URL on your server, so we'll represent the server with the database symbol for no reason other than that I'm not clear what a good server symbol is these days. So that resource will be something like, you implement this yourself, so this is arbitrary. You could call it foobar. Well, let's just call it auth foobar, /auth/foobar. This is one of the things I think is a detriment to the OAuth2 spec, because currently, with OAuth2, it's not possible to delegate authentication, and I think that as we roll forward with this peer web thing that's happening, that we need an authentication system that is federated, because, so, like, it's a shame because you have to have, like, intimate details about every individual implementation of OAuth in order for two OAuth systems to work. That's not so bad because it's basically like 6 strings where you just go on their documentation page and you copy and paste those strings and then you're good. But it's bad because you can't just like plug in me.whatever.com and click authorize, which was kind of what OpenID did, and we can get back there. But anyway, that's a tangent. Sorry, I'm really bad about tangents. Tell me to shut up at any time if I do that. So you're in the browser on your computer, and we've got 3 systems we're working with here, and 2 subsystems on your computer. So the browser is on your computer. This server is Awesome's server, and you click the login button, and it opens up a new window. So it just does window.open. They can also do redirects, but then you have a suboptimal user experience because then you have to cache all that state and bring it all back and everything. And, so I prefer this idea of you do the window.open.
So it's like a mobile window.
Yeah. So, this is JavaScript in the browser, right? I mean, I'm assuming that everybody that does Ruby does a little bit of JavaScript because you're doing something on the web. So if I'm doing any stuff that's JavaScript and it's not familiar to you, just call me out on it. This is JavaScript. You call window.open. You pass it in /auth/foobar. That goes here. This has a client secret and a client ID and a client secret. And so it constructs a URL that has a bunch of parameters on it, like grant type, response type, client ID, client secret, and scope.
So it puts them in the parameter list? It doesn't put it in the header when it makes the request?
Those are part of the URL. So like, those go to...
So they're inline parameters.
Yeah. So what will happen is your server will fill that out for you, and the reason that your server has to fill some of this stuff out is because you actually don't want your secret to ever end up in the browser. So there's a little bit of communication that happens back and forth. So in this case, it's gonna redirect the browser to slash. It's gonna be like graph API. So this, I'm just gonna do graph.fb.com, and then I forget what their exact URL is, but it's something like /authorize/OAuth/dialog. And then it's going to pass in some parameters, like it's going to have that the response type is going to be authorization code, because we're using the authorization code strategy. No, that's the grant type. But anyway, there's a grant type, and I'll show these in the slide in just a second. There's a grant type, there's a response type, there's an ID. So the URL opens up with this big long heck of thing, and then the scope is like what permissions you're asking for. Like I want to be able to post pictures on behalf of the user, because they click the post picture button, you check, and you see in the user's session we've never asked for that permission before, and so then you go out and you say, hey Facebook, I need this new permission. So if they're not logged into Facebook, they get the login dialog, they click OK, it comes to the permissions dialog. If you're not requesting any new permissions, you're saying I want photo access, well, first of all, your app will probably know that it doesn't need new permissions. But in whatever case, like if you pass in some permissions that's already been granted, then the server, the provider, there's the consumer, so Awesome is the consumer.
Facebook would be just the server you were just talking about.
Yeah, and Facebook is the provider. So the provider implements a bunch of logic to do security checks, and most of the time when we're talking about security in OAuth, we're talking about the security of the provider, because that's where the user data is. But there are cases where you, as a consumer, need to be concerned about security as well. So it opens up this big long URL. Facebook does all this magic, and it figures out this is what I'm intending to this is what this app that is authorized with this browser refer is, and this scope, meaning email, photos, whatever, is going to get. The user clicks OK, or it automatically detects that the user already done that, and then it goes back and it communicates back to the browser.
The browser or the consumer?
It actually communicates back to the browser with a code. So that code, well, I'm thinking of the way that, I'm just thinking of the other strategy, sorry. It communicates back to the consumer, but through a browser redirect. So it is going to the consumer, and it has a code. And this code says that it's a temporary code that's generally something you don't even store in a database. You just store it in memory for the 30 seconds that it's going to exist, kind of thing. So this code is given to the consumer. The consumer then speaks directly to the provider with its secret. So it doesn't include the secret here, it only includes the ID. And in this process, it includes both the secret and the ID. The provider will then check that your secret is correct for your app, so this is not someone forging a request. And then it will check that the authorization code is correct. And then it will hand you back a token that you can then use to make API calls. So code goes here, and then from the provider to the consumer comes back the token. Now, the token, you can use it in the browser, you can use it on your server, depending on the implementation of the provider. You could even hand that token to a third party that would be able to use it. So Awesome could authorize on behalf of the user, and maybe Awesome is a parent company, and it has a daughter company that's less awesome. And if you've authorized here, then we want to authorize you there. And so you can actually pass that token to this other website that's, lessawesome.com, completely different domain, completely different cookies, completely different everything. And so that's, the token can kind of just pass around at will. However, both the provider and the consumer do have some say in where the token can go and how it can be used, depending on implementation specific details. But once you've got that token, then the next step is, like every library that you encounter, the next step will be to go to the profile URL. So in the case of Facebook, it's graph.fb.com/API/2015 or v2.0 or whatever it is that they version it as, /me. So this token is then taken back this third time around, goes back to the provider, and we want to get the /me resource. Now this can happen either on the consumer or it can happen in the browser. Okay, so we're going to take a second to ask questions, because it seems like a really complicated process, and when you look at code, it looks like a really complicated process. There's nothing that I can definitively say that this process isn't complicated, so let's talk about that.
So when you say you can do it from the browser, are you talking about doing direct AJAX calls from the browser back to the provider?
Yes. So if your consumer passes the token to the browser, and this is how Facebook works, you can then do an AJAX call to any of the APIs. Oh,
That's okay, we can see that.
yeah, I guess that's true.
Well, maybe.
I prefer the other way. There we go. Is it gonna bring back up the old thing?
It's adjusting the
It's
image.
adjusting the
Okay, so let me just put this back and present on so it reflects the screen again. But once this token gets in the browser, yeah, you can access any resource on Facebook, and depending on what settings you've done in Facebook or whatever other OAuth provider you're using, sometimes there's a whitelist, and you say tokens are only allowed to be used from these IP addresses and from these refers. So you could whitelist awesome.com and lessawesome.com, and you could whitelist 123.123.123.123, and that would mean that that token will be checked by the provider to make sure that it came either from that refer or from that IP address before it actually issues any data from the user. The good news is that this is although it's the most common, it's also the most complicated of all the strategies. All the other ones are simpler. But ask me some questions.
It seems like there's a lot in common with SAML. Is there any influence between the two?
I have no idea what SAML is.
It's an authentication and authorization kind of service. I know a lot of enterprises that we work with require us to implement it.
Is it based on OAuth2?
No.
Is it like the what's that terrible XML thing called?
It is XML based, SAML. SAML.
No, what's the thing that like they pretend like it's an API, but they call it something different? That XML stuff.
SOAP RPC.
SOAP,
Okay.
RPC, yes, SOAP RPC. Is SAML a SOAP RPC thing?
I'm pretty sure it is.
Okay. Yeah. So SOAP RPC, for those that aren't familiar, is a way of saying, like, let's think of the most complicated way we could possibly, instead of representing this as objects, try to represent everything as a function with parameters instead, and give as little data back, but as much metadata as possible. And that's SOAP RPC. That's kind of like back in 2005 when people were realizing that jQuery is... No, nobody knew about jQuery yet. In 2007, when people were realizing like jQuery is kind of cool and there's this thing called AJAX, the other people that were using Java were like, we have SOAP RPC! And then like Jason like kicked him in the face with a roundhouse kick, and then Douglas Crawford threw angle brackets out of his beard and killed them all. But there's a couple that survived, and Sam was a result of that.
I hope the tape is working.
And it's totally not all of that.
You check that just in time, make sure.
We're gonna increase our hit count just from that.
Yeah.
Yeah.
Animated GIF right there.
Okay.
The DJ does karate in front of URUG.
That's right. That's exactly what I do. Okay, so I'm going to just draw this out. One more time, I'm going to do it quicker, and I'm going to use less words, but just to like nail this home, because it's important. So, we have a browser. This lives on the user's computer. It's facebook.com. We have another browser tab. It's awesome.com. And then we have our consumer and our provider as backend. I get on awesome.com. I click on the login button. It opens up a dialog window that's actually from facebook.com because it goes to here. It mixes up some parameters that are part of what you get when you click Create App on the Facebook developer page or whichever, Google or whatever. Then it constructs a URL. So we get login.
That should go up to the Facebook, not up to the window, right?
Well, this URL that it constructs becomes this Facebook window that asks you, do you want to allow?
But isn't that window rendered from the Facebook?
Yeah.
Yes.
So your request actually goes up to Facebook and Facebook goes over to the window.
So this issues a redirect. This issues a redirect. So you open up this window. That window goes to your server. Your server issues a redirect. That redirect is Facebook. You click allow. It redirects back to your server with a code. You take that code, you hand it over to the Facebook server. That issues you a token. And you take that token and you send it back to the browser in some fashion. Like the way that I do it is I actually send the token back to this window and then have this window self-close so that the user gets the token right away. But you can also make an API call to /session/tokens.
You could leave the token in the consumer and then subsequent RESTful calls or whatever calls to it can use the token to go
Yes.
access the...
Yep. Because you can now use that token. You've got two things you can do with that token. You can go from your consumer to Facebook, which means that you're mirroring the Facebook API for certain things, perhaps. You're doing /me/Facebook/the Facebook API, and then you're just kind of proxying that request directly. Or you might mix it in, or you might send it to the browser. So this is authorization code strategy. This is the most popular. This is the one that you need to know the most. And last chance for questions or comments on this.
Question, I think I know the answer, but why do you have to do the extra step about verifying the code back or sending the code back to the provider? Why can't you just use the code from then on? Why do you need to exchange it for token? Is it probably a security thing?
Okay, so the code and the secret go to the provider, and this code, the reason is this code was in the browser. So this code, because when it did the redirect from Facebook, so this URL did a redirect, which caused this window to reload, and it reloaded from Facebook with the code, which means that the code actually appears on the client.
So it's unsecure.
So it's insecure. So you pass the code back to the consumer, where it adds the secret to the code, and then hands the code back hands it back as a token, and it normally has a couple other parameters that it hands back to, like an expiration date and a refresh token. So the refresh token and the token, depending on the implementation, might be the same thing, or they might be slightly different. The refresh token might be permanent, but you can't use a refresh token for requests. But a lot of times what you end up doing is you make a request to the token resource right before your expiration date, and then you just get a new token that way. But yeah, there's also expiration and refresh that are as part of this exchange here. And you would never send your refresh token to the browser. That would be something that you'd keep here. All right, so I'm going to move on. If you have any other question, you can still ask while I'm erasing. It just won't be as relevant because it's erased.
Was it less complicated or more complicated under regular OAuth 1?
I don't remember. OAuth 1, one of the things that it did was it did signing, and it might have even done encryption. I don't remember because I wasn't really into it back then. Oh, I am on my PowerPoint right there. Okay, so grant type authorization code, response types equals code, client ID goes in the browser, client ID and secret go to the provider, scope is your permissions. That's what we just talked about. Now, let's talk about implicit. Now this, I think, is the simplest. And I like this the best because I think it provides an excellent user flow. So let me go back. Let's talk about implicit. So here, there is no consumer. There is only the user's browser. So we've got awesome again, and we've got a little login dialog. And you click on that login dialog, and we still have, and actually, this is kind of cool. No, I won't go into that.
This is all coming out of Ajax and JavaScript on the client side.
Yeah. Yeah. So there's actually a way that you could have no server on either part. And this is an authentication strategy that I think is going to be becoming popular this year and next year. Because you can actually, there's this project called, never mind, I'm not going to go into it. But it's going to be possible to have users authenticate without sharing any of their personal information. And so it's going to be just authentication and just what the user specifies. There won't be any requirement for Facebook. And I think that that's going to catch on either this year or next because that is something that's cool and it really respects privacy. But I don't have time to talk about it now other than to mention it. Okay, so what happens here is I open up a modal window just like I did before, except this time I only provide the client ID and the scope. I never use the client secret. What I'm calling client ID and client secret, I should have said this before, they're sometimes called consumer ID and consumer secret, or app ID and app secret. But it's like the ID of the application or the client.
Are they all synonymous?
Yeah, they're all synonymous. So I'm passing the client ID and the scope. It's going to open up this modal window that again is going to ask for those permissions. But what it does is it checks the refer. Like it's required to check the refer on this, and it has to be in an allowed list of refers. Because we know that no browser on the market is going to misrepresent its refer. And we also know that the only way that this can be hacked is like something, it's easy to do with curl or with Ruby or with Python or Node to misrepresent the refer. But here's the thing, is that since the user has to log in, like they're supplying their username and password, and so the secret is just taken with the idea of the session over here. So we're supplanting the secret entirely with just knowing that we have a refer, and we know that the only way that we're being lied to is if the user is doing a curl on their own account, which we're not worried about. So we have this kind of guarantee of security, but the downside is, so I open up this window, it says, do I want to allow this? A person's picture, whatever, and this is Facebook, right? I click allow, and then it hands back the token directly to the browser. Now, these are the downsides to this approach, is that, one, the token normally expires quicker. So with Facebook, as an example, their tokens last, I think it's 90 days on the server, and they last like 24 hours in the browser. Now this isn't really a problem because you can just have an iframe that opens up in the browser and like automatically does this for you every single time the person visits the page. And you can also store the token in local storage with the expire time, so you'll know whether or not a user is logged in. And if you have an expired token, you can open up this iframe. So instead of showing the user this, you can open it up in an iframe so that the user never sees it because they've already allowed it, so it'll just automatically happen in the iframe and they never have to interact with it. And that's
So
how...
you're kind of doing allow behind the scenes.
Yeah. Well, they've already clicked allow once, so they don't have to click it again. You know, because a lot of times when you click on that login button, it just like flashes and then it goes away. And so you can just get rid of that flash by doing it in an iframe. And if the iframe times out, you know, you set a timeout and say, if I don't get a response within 3 seconds, this user probably has an allow dialog that needs to be clicked on. And so then you open up this one, you know, you open up the real window instead. So the token will expire. The token is generally tied strictly to the referrer.
And in this case, Awesome is the referrer.
Yes, so awesome.com would be the referrer. But in Facebook's case, and I would imagine in many other cases, this isn't part of the spec, but I mean, it's implementation detail. You could then take that token if you wanted to. You could pass that token to your consumer server, and then you could validate it against Facebook, and then you could receive a token that's good for 90 days. So this is really nice because it's going to be faster, you're going to have better user flow, you store that token right in local storage or an index DB, and then you can be serving completely static assets without any server action whatsoever. And if all you're doing is using data from other APIs, then you don't even have to have a server. You can host this on GitHub Pages.
Because it's completely static on the server side.
Yeah, so if you wanted to host this on GitHub Pages, you would just use local storage to store the token and the expire date, and then just every time the page gets opened, you check local storage, you check the expire date, if it's expired, you try the little iframe trick, if it fails, you present the user with the login dialog. And by the time the user's gone to click on the login dialog, you've already done all that logic, so, you know, like, really nice experience. And so this one's pretty simple. It's still got internal logic over here if you're implementing it. It's a little bit complicated, but it's just, I like this one the best.
Is this what you use for the API scenario I was describing before?
What's that?
Is this what you would use for the API scenario I was describing before?
Tell me again, the API scenario?
Where I've got a tablet that authenticates against Google, and an API that the tablet's going to be consuming to get data. It's not actually getting data from Google, it's just using Google to authenticate.
But this, on the tablet, are you talking native or are you talking browser?
In this case, it'd be native.
Okay, so that's what we're going to get to next. All right? So any questions here? We just call window.open, we give it our client ID, we never pass our client secret, we get a token back, we can use those tokens to make API calls in the browser or the server. It's simple.
Yeah. We're still technically authing against Facebook in this one. It's just it's never hitting another server. It's only in the user space, right?
Yes, and there is somebody. Well, there's two of us. There's me and there's someone else. I was inspired by him. I'm going to take a look at his work, see if I can fork it, see if we can merge or whatever. I'm not at that point yet. But there's a guy who's implemented OAuth in the browser. So you visit a static page that you hit once, and it implements all of the server logic in the browser. So it just checks against IndexedDB to see if that app is allowed. And so you get a token that the only thing that you actually need a server for is if you have two devices, you know, your laptop and your phone. You just need some sort of either peer mechanism or a server that will pass the server side IDs back and forth between your devices, and you could have no server other than that, and then you completely put all the privacy in the user's realm. And I think it was called Keyboot, I think is what the project is called, and it's Substack is the guy that's doing it. And it looks really cool.
And the mechanism for passing between, say, two devices, my tablet, my phone, could be me.
Yes, because you could just open up a peer WebRTC connection. And so you could be like storing your photos and storing your data on like your own home cloud or something, or you know, like, and then just granting access through that mechanism. So I think there's going to be a lot that comes out of that in the next year or two. All right, so we talked about implicit. Are we going to talk about this one right now? Yes, we're gonna talk about this one right now. Okay, resource owner password. This strategy is the mobile device strategy. So if we go back, I kind of put this on there. Authorization code is browser server. Implicit is browser only. Resource owner password is mobile, or that's like the primary use case for it. And then client credentials, we'll talk about that in just a minute. And then I'll do a demo for you. All right, so this one, the grant type is called password. The previous one, I don't know if I mentioned that, but you don't do a grant type, you just do response type equals token. And you don't necessarily need to put in your client secret on this one, depending on the implementation, because, well, actually, in this one, no, you don't want to do your client secret. It's optional on the next one. I got these two mixed up, right? Client credentials. I think I get confused with the names sometimes, so I might actually be explaining it by the wrong name, but I think it's the right name, and I just got that one detail mixed up with the next one. Okay, so this is your mobile situation. So you have a native app. The problem with your native app is, so you present your native app, you've got your awesome logo here, and the user wants to log into your native app. That's what this resource owner means the individual, the person who owns the data. I own the photos. I own the wall posts. So I'm the resource owner, so it's my password. So I put in my username and my password in this app. Now the app is insecure. You should never, ever, ever put a client secret in an app, because as soon as you publish it to the Android store, anybody can download that APK, open it up, and see your client secret in plain text. And you can do some jiggery pokery, but if you can do some jiggery pokery and they're, kind of wanting to, well, they can just modify your APK to do a system.puts, and then, even though you've got this jiggery pokery, you've got some point where you're going to be passing that, and they can just system.puts the URL and get your secret. So you don't ever want to put your secret on a mobile device. It's completely insecure. You don't ever want to put your secret on a desktop. What you do instead is you supplant your secret with the user's secret. So I put in my password here, and this is the thing that you're assuming. You're assuming that the user's smart enough to download Twitter app from twitter.com as opposed to pirate Twitter app from evil.com. But if they're downloading the app from evil.com, there's not really anything that you can do to secure it anyway, because that becomes a social issue, not a code issue. But this sends that to the server. So in this case, I just said Twitter, so we'll call this one Twitter. And so it sends the username, the client ID, and the password.
And this is all on SSL.
Yeah, you'd want to do this over SSL. Yeah, you don't want to do any part of OAuth not over SSL. It doesn't really matter which version it is. OAuth 1A, I believe, is the one that's more secure without SSL, but nothing is secure without SSL. I did not realize how big of a problem HTTP is until I recently got into more security-focused study and watched some YouTube videos where people explain all the ways that you can break HTTP connections, and it's bad. You do not want to be using unsecured connections ever for anything, ever. It's just bad all the way around. I mean, even in a simple case, anybody that connects to a Wi-Fi, that means that your site can have ads injected to it by that Wi-Fi point, or that coffee shop owner can be stealing the user's passwords while they're on their vacation in Nicaragua or whatever, right? Anyway, so you send client ID, username, password, and then same thing, you get back a token. And that's going to have an expiry, and it's going to have a refresh token. And this is how you do OAuth on a mobile platform. So if you're interested in using OAuth on and the reason that, because obviously you can just do this through your /API/sessions or /API/logins, whatever it is that you're implementing with your OmniAuth strategy already. You could totally do this, but then you have to store the cookie in the app, which is not too hard, but you got to store the cookie in the app, and that means that you have to have a cookie parser library, and you have to be able to extract the expiry of the cookie, and you got to do all this cookie management. And so basically, when you're using OAuth, if you're using a library that does all these things, then you get all those strategies for free, and you only have to worry about the token and the expiry instead of having to worry about cookies or other session types. So that's why this is beneficial as opposed to just directly making the call. Plus, also with the client ID, yes, anybody can get the client ID from the APK or from the iOS package, especially if they root the phone. But you do have like a slightly better guarantee because it's more, it is more work, and there's just going to be fewer requests that are coming without an ID, and you can push a new ID on every update. So, just to keep things fresh. So the attacker would constantly have to be like getting the new client ID, and I'm just not really sure what they could do. I guess evil.com could publish fake Twitter, and they could use the real Twitter's client ID, but I don't really know what that does for them, So any questions there? I'm gonna take that as a no. Oh, no.
I don't want to monopolize the meeting with my own use case, but I'm going to anyway, I guess.
Do it.
So, in my case, I'm just using Google for my user base. And so it authenticates against it, returns the token back to the application, to the application. And then I've got a third piece down below that's the API. So the application then is going to hit up the API and make requests against that to get data back, which is what it's going to be displaying.
So let me draw this out real quick so I can understand it better.
Oh, you could have just left that and drawn another box below it.
Okay, well, let's do that then.
So that's your app.
So this is app,
And then below it, you have API.
right?
Yeah.
All right, so what you're saying,
And the API is connected to the database, and it's got the RESTful interface that the app is going to use to consume data out of the data warehouse.
this is what I would do if you want to keep so here we have Google, right?
Yeah.
You probably actually want to do this in a web view because I don't know if Google allows third-party, this is something where oftentimes this is first-party apps. They don't necessarily allow this for third-party apps, depends on the provider. So you have to check with Google and see if Google allows this strategy to third-party consumers. If they do, then you could do it this way. If not, you open up a web view and you do it the way that we just talked about a moment ago. But if you can do it this way, in either case, once you get the token, whether you're doing it this way or you're doing it the previous way with the web view, once you get the token, you pass that token to your API, you go over to Google and you make any request, /me, just to validate that the token is a true token. Once you get that response back, you know that the token is real. So, and you should have some authenticating data that you can cross-reference, like an ID for the user. So if the user gave you ID XYZ, and then you send the token to Google, and Google comes back and gives you the ID ABC, well, you've got a valid token, but it's not for the right user, so you know that you're being, you've got some problem there. So,
What about having, I don't want to monopolize it, so I've got some other ideas and questions, but I'm wondering if I even need to do, because I'm not consuming anything on Google, if I even need to do the authentication from the mobile app and have the API do the authentication, have it all go between the API and Google only.
but you need to get a token or something
The mobile
to
app's
store
going
the
to
mobile
have
app.
to give me the username and the password, and then I can return a token to the mobile app that it could pass to me on request.
So but you would need to be using this strategy if you wanted to use the username and password, because you cannot do that from your consumer. That's not allowed. I guess you could, but it would be against the policy, if they even allow it for third-party apps. Or you could log in directly to Google, without using their OAuth API at all. You could just be hitting /login.html with a post and some form data, but that's going to be against their privacy policy.
Yeah.
So you could do that, but it's not. This is the appropriate way of doing that, or the previous way, but you need a web view for the previous way. And there's probably technically a way that you could do it without a web view by getting the user's credentials, but then you're like evil.com. So we don't want to be like evil.com.
Or Rob Lowe, crazy program at Rob Love.
Yeah, All right, and the last one before we do some demos is client credentials.
I got a question for you.
Oh, yeah,
On that
sorry.
last mobile strategy, so the user has to trust the mobile site with their Google password in the case, is that right?
Yeah, so the user would be trusting the mobile API. So with this strategy, with that mobile strategy, it's usually for first-party apps. So Google releases 3 apps that are by google.com in the App Store. Google will use that strategy for itself. It may have close, trusted partners that it allows to use that strategy as well. Or another thing is it may limit what a third party is able to get. But since you have the username and the password of the user, then they just kind of have to trust you not to do shady things.
Well, when you go in and set up the developers setup on Google, it asks you which APIs you're going to enable. So the person who's developing the mobile app has some control over what they're going to expose, right?
Yeah. All right, so any other questions on that? All right. Sorry, it's been a lot of talking, not a lot of code, but we'll get to a little bit of code, even some Ruby code. So client credentials. This is another really, 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 really simple one, like super simple, but its use case is limited. Client credentials is just between the consumer and the provider directly. So this is it's the antithesis of the implicit strategy. The implicit strategy is just between the end user and the provider's website. This one is explicitly between the consumer and the provider. And there's no web interaction at all.
When you say web interaction, you're talking browser type.
Yes. Yes. Sorry. Thank you. So I send my ID and secret, and I get back a token. Or perhaps I get back a resource. I think you can do both ways. So what this is useful for is if you're storing some data about you on the provider, or you want to manage some settings about the service that you're running on the provider.
This isn't a user-by-user ID that you're sending, it's the application's ID.
Yeah, so sorry, I should have put that up there. So this is what I've been referring to as the client ID, which is also called the app or the consumer ID, depending on your framework or the paper that you're looking at. So that's terribly written, but client ID, client secret. And so that is, it's for let's say for example, you want to send, maybe you want to send an email on behalf of the user or something like that. Maybe you have some sort of token that represents the user's email and you're doing this on a system level. But generally it's not anything to do with your users, it's just to do with services that you get. Like maybe the provider has a scheduling system, or they have, maybe it has nothing, maybe it's not a Facebook type provider where the provider has users that you're interacting with. Maybe this provider is something that's strictly a service provider, like an image resize API or something like that, where they also have a web interface, so they like using OAuth2 because it makes it easy in those, to have, to get all in one. But it's really about your app communicating on behalf of the app, not on behalf of a user. So this one is not as often used, but in cases where you're providing something as a service, I'm trying to think, like the image resize API makes sense. You're providing image resizing as a service, and I have a user base of 10,000 users that I want to resize images for, and I'm going to use you as the service provider for that. So I create an application with you, but I'm actually managing users myself, and I'm just using this as an authentication strategy instead of HTTP basic.
So you create some kind of queue with images you want to have resized, and it spits them back and forth.
Yeah. So that's kind of the idea here. Any questions about that one?
Is this the approach I'd use, like let's say the very real example, internally we have two systems and we want to make sure that they're the right thing. This is what we use to authenticate the systems internally with themselves, or would we use another approach?
No, that would be a good approach. I would layer that approach with, okay, here's the thing. Internal systems are vulnerable systems. So make sure that you are communicating with valid certificates over HTTPS internally. Don't think just because these systems are internal that means that it's okay, because a lot of these credit card hacks have been because the person wasn't able to get in to the credit card server, and they weren't able to get into the main application server, but they were able to somehow get inside the company, and then they were able to put a bug on, maybe it was somebody's downloading porn and they get this virus. I mean, I don't know how they might have targeted the company, but they just get a bug on somebody's computer inside the network that listens promiscuously for all traffic, and then they funnel the traffic that matches a regex pattern back to the attacker. So just remember that whatever strategy you're using, even if it's internal, always HTTPS, because you're vulnerable from your actions of your employees.
So porn is bad. Porn is bad.
Yeah, that's true too. If we want to talk from a purely technical perspective, it's just a very big attack vector. Okay, so that's done. Now I'm going to show you how you can do this in Ruby. Okay. And I've got a demo for the two strategies that I showed, the client-server strategy, which is the authorization grant access code strategy one, yeah. And then I have another demo for the implicit strategy, which is the browser-only strategy. Okay, so let's see if I can, let's see if the demo gods are with us, which I think they will be actually, because I've done this demo several times now. All right, so I'm going to go to like GitHub's. I'm working on a project called LDS Connect, and just kind of as a brief intro to that, LDS.org has an API, and when you go and you talk with developers at LDS.org, they're like, oh, all the members want to do cool stuff, and we want to let them, but there's this old dude in management that's got to die. And so they can't get like official leeway to start this new project. Plus, the church is organized with portfolios, and so the authentication services is in one portfolio, the member directory services is in another portfolio, and so there's all these, family search is another portfolio. So when you want to have something like OAuth implemented, that means that the managers of all 16 portfolios that are all touched by that authentication system all have to say okay. And so I went rogue and I created my own, and I am in talks with people at the church trying to get to those managers so that hopefully we can merge this at some point. So because I want this to be really simple for developers, I've got examples for Node and for Ruby and for a couple of the different strategies.
If you're going to be on the projector, you can pull the screen down.
Oh,
and show that
yes.
for us.
Yes, thank you. I forget. Yeah. I guess I could make this larger because that projectile. Okay. Too big?
Well, I don't know.
All right. Well, anyway. Let's see if I can find my backend that's in Ruby. Ruby Sinatra. Okay, and there was somebody else that actually made an OmniAuth for it. So if you want to see like how that's done, you can search for the OmniAuth one. But I didn't remember about that one, so I didn't create an example for it. So I had another buddy who we traded time. He did a little bit of Ruby for me, and I taught him a little bit about OAuth because he needed to do an implementation of something else. So we just did a little trade. Okay, cool. So let me open up my terminal. No, I need a tab with Solarized Light and make it big. So if you're doing your own implementations, this is actually a really good one to try from because, Jim installed bundler. That's right, I go to sudo. Whoops.
Just a quick question. Was your comic book distributed by LensCrafters?
What?
The name of your computer?
No.
Obligatory Simpsons reference?
I actually
You actually don't know that one?
I called it Biclops because I have dual displays. And so I had reinstalled Yosemite Fresh because I was having problems with it. Turned out that it had nothing to do with being installed.
I thought I was seeing a very underground Simpsons reference there.
Sorry.
Darn.
You watch too much TV.
I know. Hey, imagine if I use my learning for good today.
Stay away from the TV.
Alright, so I do my bundle install. Now, this is a really good repository to start from because this has SSL baked in. It has real certificates that you can use in development that validate. And it's got the OAuth stuff in it. So I'm going to git clone the certificates. Alright, so the certificates are there. And then I'm going to clone the jQuery front end. And then, junk. I don't remember what I'm supposed to do next. I have to do Bower install? No, I don't, because I'm not using
How
it.
about if I do this?
I just got to do Ruby app break.
Is that better? Started squinting.
Okay, so let's see if this works. I probably should have done a print there with the domain. So it's local.ldsconnect.org 8043.
Is it still running?
It's not on HTTPS, is the problem. HTTPS, it defaulted to HTTP. Alright, there we go. So here we are. Let me make it big. Well, maybe not quite that big. So this is just like really, really basic jQuery code. So if you look at this, you should be able to understand it without any problem and like model after this. And just to prove that it works, I click the login button. I'll go ahead and, I think this example works with, no, I didn't implement it with Facebook and Ruby because my buddy didn't have enough time to do that one. So we just did it on this one. The node demo. No! Where's the callback? No. Demo gods are not with us today.
What's they call that today? I think callback code and then something test.
Okay, I promise you that I tested this and it was working. I promise. You know, it's probably because like I had a system update that updated the version of Ruby or something like that.
Are you connected to the net?
I think I'm connected to the real net, yeah.
Yeah. You got Google. Okay.
Okay, so, side rant, moment of honesty. One of the reasons that I switched from Ruby is because every time I did any update to my system, everything that I had programmed would break. So I know that you guys probably use RVM and you've got your system set up like super nice so that like you never have this problem. But I have this problem all the time. I need to learn that stuff, I guess. I just didn't get into it enough before I switched. Okay, so I guess I won't do this example, and I'm really sorry about that, but unless somebody can tell from these, like, what it is that's upset. Because the certificate's valid, it's something in the application framework, sysread non-block.
It's an open SSL, so it might be a cert thing.
Well, it's a valid cert, and I tested this specifically with SSL because I feel that that's really important, so I had this nice demo. Okay, so I guess I'll get with my buddy who does some Ruby and see if he can help me figure out what went wrong with this. But I will show you a little bit of code from it, just for
Is that the correct callback URL?
Hey, that's a really good thing to check. Auth LDS connect callback, I think that's what I called it, but let's look at the code and see if anything in the code is like glaringly obvious. Like, you're an idiot, AJ. Okay. I wonder,
There's your redirect URL on 19.
yeah, and the redirect URL looks correct to me. And then we can go down and make sure that that callback's implemented. Auth LDS connect callback. Let me make sure that file is in there. Maybe that file has a different name now. OAuth close, no, it's there, because I did name it OAuth2 close. Alright, well, so now that you're actually looking at this, it's not so complicated as it seemed on the board, because it's like very, very, very little code. So all I did was this right here, this does the redirect to the authorization URL. So my strategy, I create my strategy with the OAuth2 library, which is actually required by LDS Connect. So my strategy is ldsconnect.new. This is just a subclass. I pass in app ID, app secret, and my redirect URL and the permissions that I want. And then I just have it do the redirect. The strategy, puts those things together, the client ID, this client secret, whatever, and it manages that first handshake. Well, the client secret isn't in the first handshake. And then I get the callback from the provider, which is ldsconnect.org. And then when I get that callback, I grab the code, and then this get token just makes the second half of the handshake.
So it's actually getting into that code block for the callback?
This one?
Yeah.
Yeah, that's the URL is on now.
I'm thinking it probably isn't, but
Well, let's just try it.
And another thing, if you're running this locally on your own machine, Sinatra's going to be single-threaded. So if you're posting back to yourself, while you're there loading the page, the other request can't come in, so it'll be a blocking call, I think. But,
No, they happen separately.
okay.
It's not in the same block, but that's good to know. I think they happen separately.
This is waiting.
Oh, there's also another very good possibility is that I was having a problem with my proxy server where it was kind of like going down sometimes. So it may have actually been not, I take everything I said back.
so it got through.
So you know what it was? It was probably the proxy had a hiccup and didn't respond to the request.
No, I think I fixed it.
And it might have been you fixing it.
It's a push block.
Oh, it's probably going to tell me no because I'm logging in with my real account, but that was with a test app, and test apps don't allow real accounts. So it might come back and say, everything exploded because you're dumb. Yes, that one right there, that everything exploded right there was because that was a different problem. Let's try this one more time. One more time. And then I'll show you the other strategy, which is browser only.
It's very performant right here.
No. Well, so I'm kind of in the middle of some stuff. Like I'm actually transitioned LDS Connect from version 1 to version 2, and they're both not very performant right now, and it's somewhat intentional. Well, I mean, not intentional that they're not performant, but I don't have it set up in an optimized way, and there's a proxy that's like really slow in between because I'm trying to separate assets from API from sessions so that it's more secure.
So if this were live and real, this would be a page from lds.org right here where you log in, right? Or would you be taking those credentials and then passing them on?
So what I actually do in reality with this right here, well, this is marked as a test app, so it says it's not allowed to accept real usernames and passwords.
Connection reset.
Yeah, so it might be something wrong with the proxy, but I can do the other demo. I just did it right before I came, so I know that one works. And I can check out what's wrong with this one, but it's probably because I have it behind a proxy and the proxy is not configured correctly, and so it probably was timing out on the request.
They may block some stuff here too through the firewall. Oh, are you going through your phone or are you going through?
He's plugged into the Ethernet.
Yeah, I'm plugged in through the Ethernet. But what actually happens right here is it takes the username and password, it's on the API server for a split second, and then it gets, so I actually delete the variable as soon as it's sent it to the session server, and then the session server encrypts it and passes back a token. And that token is actually the decryption key. So if you had physical access to the session server, you would not be able to retrieve any session information from that server. Because the token is actually, you have to have the token in order to be able to decrypt. Like, you can't even, first of all, the token is hashed, and that's used as the ID, and then the token itself is the decryption key. So in order to know which column in the database it is, you have to have the token, because you have to have the MD5 sum, or the SHA-1 sum of the token. And then in order to decrypt the data column of the database, you have to have the token in order to decrypt it. So, because I'm doing something that is, using somebody else's API, I'm like PCI compliant paranoid about security on this. And I could be mistaken, I have to do some more research, but I think that my system actually is PCI compliant. Anyway, I'll switch to the other example. So I'm going to do, instead of doing that front end, I'm going to do, should we do jQuery or Angular?
Angular.
Do Angular? Okay. So they both work the same. Actually, I'm going to do jQuery because that's the one that I tested right before I came.
Yeah, don't listen to him.
All right, so we've already done all these other steps, and so this time I'm just going to clone this repository, and I'll show you the, move this to public.authorization code, and then we'll git clone this public. Oh, I did git clone twice. Let's see, where was I at? So now I'm going to refresh it. It's going to look exactly the same, but it's a different backend. Oh, I got to restart the server. Alright, so it's all the same stuff except for a little bit of JavaScript is different. I'll show you the JavaScript in just a second. No.
Same error.
No, this is, hold on.
It's over here.
Did I copy?
Reset right here.
I think I just copied the same thing over itself. I didn't actually get the different one. But cancel that out. Cancel this out. Let me go back. This one is the one I should be cloning. Okay, so it would have helped if I updated the instructions with the actual repository that I'm using when I cloned it, because it just cloned the same repository as before. So I will update those instructions. Okay. So we go back here. Click login. LDS Connect. All right, and this is my little beta one. And I think it's going to see.
So now you gotta tell it allow, yeah.
So it's a little slow because it's making requests back and forth through that proxy, but that should have been like that little flash window.
Nice.
And that all happens in the browser. And so I think I'm actually doing this where if I refresh this, I was saving that token. So in just a second, yeah. So I actually saved the token that I get to local storage, and then when you refresh the page, I check the token, and then I check that it's valid, and if it's valid, I present you with the logged in screen rather than, or the user is already logged in screen as opposed to the welcome to the page screen. And so I'll show you the important bits of that code. Oh, I didn't push that yet. Oh, no, that's the different one. Okay, let's make this a little bit bigger if we can. Oh, I didn't put the little JavaScript tag around it yet. So there's an important file that I have, that OAuth close is what actually responds to stuff. So this is kind of the way that it happens, is I open a new window with this URL. So this URL is to lds.io, that's where my version 2 API is being developed. The version 1 API doesn't actually allow the browser side, well, not that it didn't allow it, it just wasn't implemented. So this is exactly what the URL looks like. It's my authorized endpoint, response type is token, so that's the implicit type because there's no grant type, it's only response type. Client ID is my app ID, the redirect URL is my app domain, which is HTTPS, and then it redirects to OAuth2.html. And that is a blank page that has a little bit of JavaScript that checks for the token, and then makes a callback to the original window with success or failure. That way, it's not like the user's going to an authentication page and then coming back. It's the authentication page opens up, and then the main page waits for the authentication callback, and the user never loses their place and what they were doing, because it doesn't actually redirect the main page. And then I have a scope. My requested scope is just a me resource. That's the profile resource. And then state is just to prevent like replay attacks and stuff. And I open that URL, and that's what pops open. Then the next step, let's see, invoke the login dialog. Yeah, so the next step, I should have done these in a different order, is this callback gets fired. So I have window.complete login, and because I allow different strategies, Facebook, LDS Connect, whatever, the OAuth close.html will pass back the name and the URL, and then it's up to me to test the URL to see if the token came back. Like I wanted to make it as little JavaScript as possible, so I didn't, in that OAuth close.html, I don't do parsing because that would require some sort of 100 lines of URL parser library. So it's up to you in your application to then parse that URL. And then I just do some funky magic, regex magic to grab the token, and then I call test access token. And so then down here is where I have my test access token. I just make an AJAX call, and that is undefined on purpose. That's just a me thing right now, because you can log in with a session or you can log in with a token, and if you're logging in with a token, right now I leave the ID of the account undefined because it finds that out once it parses the token and checks it in the database. So that's why that's there that way. That's just a me thing. And then authorization bearer is where you actually pass the token. And then I get the data back, and that's what I print to the screen. Cool. And then just for funsies, I will do the Angular one as well. So jQuery example, Angular example. So I'll run rough public, and I will git clone Angular as public. Okay, so that's started. And the interface is going to look almost identical. It's just that I did it in Angular. So if you want to see an example of how to do this kind of thing in Angular, you can just copy this as a bare bones template. Oh, and it checked that I was logged in and found that I was logged in, so let me log out. Oh, I didn't implement log out. How in the world does it know that? Oh, because it tested the token. Too smart for my own good. Where did it go? Oh, I didn't do bower install. That's what's killing me. Okay, it wasn't the session was logged in. It was that I wasn't actually running Angular on the page. Okay, there we go. So now this is Angular instead of jQuery.
and it works just the same. And this would be instantaneous, but it's slow. And then apparently my final callback failed, so I'll have to, oh no, it worked. I was just waiting for the...
Earthquake?
Just a little one, it's normal.
So anyway, I won't really go over the Angular code because you guys are Ruby guys, and that's like not just JavaScript, it's Angular on top of JavaScript. But any questions you have overall, or any code you want to see that I didn't show? Because I kind of just let the OAuth library handle some of the dirty work and showed you what was more the application layer, which is hopefully what you guys are dealing with.
Yeah, I have a question.
Yeah.
So it's popular now to do SOA, do your services-oriented architecture. Do you think OAuth is a good option for controlling logins among different services? And which version of OAuth would you use?
So I think that we need a version of OAuth 3 that is simply a subset of OAuth 2 that, one, as an addition, the only addition I would say is to add signatures so that you can know that it's from the source that you wanted, especially when you consider like the peer RTC, WebRTC type things that are going to be popping up. We do need something that can verify better than HTTPS alone can. But we need to pare it down to like, everybody just calls it /OAuth3/authorize, and that is it. Final word, no choice. You know, or at least there's a /OAuth3/endpoints. That way, if you know you've got some proxies and you've got some services here and there, you know, you can at least return and say, these are the 6 strings that you need now, go build that library yourself instead of me copying it, hand coding it, and pushing a gem for it when all I needed to do is change 6 strings. To answer your actual question though, I think that it's a really, really good framework to use. I think that you can pass, because you can whitelist, you know, IP addresses and refers, you can pass tokens around between the different services in your architecture. And with my recent experience building LDS.io and LDS Connect, I would highly suggest that you consider a way to pull your sessions out into their own service and design your API so that your API only accepts tokens. There are no cookies. I haven't gotten there yet because I'm doing this step by step, but I see the path, and I believe that that is going to be the way that I'm going to go, because it seems you just get so many benefits from isolating your sessions, which is where your passwords and credentials are, to a server that you can secure more tightly, you don't run any other services on, you know, you really can put your thumb down on that one, and then have your other servers, which hopefully are just as secure, but I mean, in any case, you know, you can spread those tokens throughout your services and use that session server as an endpoint that could have OAuth2 on it. Does that answer the question, or did I just ramble?
It gave me some info. Yeah, that's good.
I'm sorry, I mostly ramble, but it had nuggets in there. Good.
On that same token, not to use Hey, I'll be here all night, take your waitress. Using it to control access like in an organization, is there an established standard to say that this user is asserted to be like an administrator or something like that, so that when they log in on this machine with their OAuth token, I can infer they have rights to do whatever. I know I could just like say that I want to have access to like a string or something, column roles or something like that, but is there an established standard for asserting that somebody has certain rights between systems?
Okay.
If you can get where I'm going with that.
I get where you're going with that. I've actually been thinking about that. I don't believe that there's a standard. If there is, it would be something supplementary to OAuth. I mean, there may be one. As far as I know, there's not something that's like a baked in, like here's a strategy that includes that. But what you can do in your implementation details on your server side, BT dubs, I do have a full OAuth server with all 4 of those strategies implemented in Node.js. Not that you'd want to touch that, but if you did, you can ask me about it because I've already got it built. Or if your organization needs an OAuth server with those different providers, I can do that for you. But what I would recommend doing is either putting that in the scope and then denying the scope in your implementation. So like I want to log in with this user with admin rights on groups. And when I check that scope on my server, then I would look up that user in the database to see if they had admin rights, and then I would deny that scope. That's one thing that I did not mention. This is relatively new, and it's not, I don't think, part of the spec yet. But because users can checkbox, like I do want to allow photos, I do want to allow whatever else, in your response, in addition to the token, you will also sometimes get a granted scope parameter, which will be like, you asked for these 5 things, but you were given these 3 things. So granted scope would be necessary to implement in this case.
But the scope I asked for and all the available scope would be something I would want to hide.
Well, I don't think it's necessarily something you want to hide. Oh, well, the all available scopes.
That's what I'm meaning. Not that I don't know if it would return that in response normally. Probably not.
I don't think that granted types always gets returned. I think it's in newer systems that implement the checkbox style authorization, which Facebook just implemented a couple months ago. But again, that's not really, that's an implementation detail in your user and your session logic that you can check there. You can use OAuth because it has scopes, and scopes are just a space separated or space delimited list of mostly ASCII characters with underscores. So you could use it for that, but you still have to have your logic where, in your user management system, you check a box, and then whatever those check boxes are relate to in the database, they need to be implemented in your scope callback function.
Okay.
Or scope handling function. Anything else? I went way longer on this than I thought I would, so I totally apologize for that.
I appreciate the presentation.
Yeah, we're good? We good? Good.
No more questions?
So, quick question and plug with my project. Are any of you guys LDS and interested in developing things like home teaching apps, texting reminders, that kind of stuff?
Yes.
Then we should talk.
I'm LDS, but I'm not that interested in home teaching.
That's fine too. It was more about the apps.
Oh, gotcha.
Yeah, because I'm building out this API. The reason that I built version 2, well, it's for a number of reasons, because I'm actually using the same provider with other customers and clients that I'll be working with and in my home cloud system that I'm building. But version 2 was some work that I had already done somewhere else and then brought it in, and it was just easier to scrap the old code and rewrite. Plus I found out about some APIs that the church didn't have at the time that I wrote V1 that speed up the process by like 1,000 times of being able to get a profile. But I have it so that all the data will only be allowed to come in through the browser. So of course you could take a token and then fake it on the server, but the idea is that in order to keep in alignment with the church's privacy policy as best as possible, the data would only go to the end user's machine, so that there's no privacy concerns about the data ever touching your server or how secure your server may or may not be. But then of course on your server you're going to want to do things like send text messages, send emails, yada yada. And so I haven't finished this part of the API yet, but what I will be giving is in the web interface I'll also be giving email token and phone token. So if you have asked for permission to be able to send a message to the user, then when they allow that permission, you'll get an email token or a phone token. You can take that token and the user's ID, send that to your server. Now there's no personally identifiable information on your server. The privacy is 100% guaranteed because that token is unique to your app and the user. And then you can send that token back to my server, and then my server will be able to send out an email with a template where it has the user's name, it has your message, it has, whatever it is you want, that kind of Angular/mustache style brackets in a text template, where you would then be able to send that user out a message that's completely personalized and customized, but you'd never actually know the name of the person that you're sending the message to.
There's your PCI compliance.
Well, that among other things, like separating the session server from the API server and the asset server, that's also part of it. Because the asset server is front-facing and you could directly hit that from the web. And so I have this really slow proxy because it's actually a node proxy and it's running on a very low-power device, so it's doing double SSL because it's got the SSL and then it has the SSL again to get through the proxy, and the proxy is in JavaScript instead of being in C like it ought to be. Just because I was creating a quick and dirty demo. But so what I do is the asset server has all of the static files and it doesn't have any of the API on it. And that's going to be LDS Connect. Then the API server actually allows cores. So LDS Connect will make a request directly to LDS.io, and that refer is one of the only allowed refers. Like I have a whitelist of refers that are allowed to use that cross-origin resource sharing. So that comes through to the API server. The API server will, if it gets a username and password, it's literally in memory for this much time, and it's only in memory. And it would never come out in a log, even if there was an unhandled exception, because it's isolated. There's a copy of it made to a specific object. As soon as it comes in, it's deleted from the original object so that that object can continue to be passed around if it needs to. That copied object gets sent directly to the session server, and then as soon as there's a callback from the session server, error or success, it's deleted from the object on the API server. So the password is only there for just that smidgen of time. And even though if a person got root access, there's potential that they could access memory and be able to read it out of memory and it wouldn't have been garbage collected yet. We're talking like 30 seconds or a minute before it's garbage collected. So I feel really good about that. And then in the session server, like I said before, it goes in, it immediately gets encrypted, and it's actually encrypted 3 times because the database itself is encrypted as a whole. Each key in the database is encrypted, and each ID in the database is the hash of the encryption key, which is stored elsewhere. So there's a lot of pieces in there, but like security is of the utmost concern to me for this because it is very sensitive data, and it would be, I have a level of confidence that if you had physical access to my servers, you would not be able to get any data off of it, and that makes me feel okay about what I'm doing. All right, anyway, I'll pack up.
Thanks, AJ.